Good day everyone! So for today, we're going to discuss about naming covalent compounds. Okay, but before that, let us recall that compounds can be classified as inorganic and organic. And inorganic can be classified as ionic compound or covalent compound. Right. So for ionic compounds, you can easily determine if a compound is actually ionic compound with just a glance of the formula. If you see in the formula or in the chemical formula that there is a metal and a non-metal. And also for covalent compounds, you can confirm that the compound is actually covalent compound if you see in the formula that there are only non-metals in it. So there you go. Alright, just a quick recap. Okay, so before I proceed with naming covalent compounds, if you have not yet watched naming ionic compounds and naming polyatomic ions, I recommend that you watch that first before this one. Alright, there you go. Okay, so now let us focus on the nomenclature. Okay, so for today's discussion, we will only discuss the nomenclature for binary compounds of nonmetals. So when you say binary, that means that the compounds that we're going to use for today are those that has only two types of elements, alright, or composed of two different elements. Okay, so that's it. So the rules in naming molecular compounds or covalent compounds are the following. So number one, use prefixes for both elements present, but the prefix mono usually omitted for the first element. And number two, add IDE to the root of the second element. Now, the rule mentioned about prefixes. Which prefixes are we going to use? We're going to use the Greek prefixes. So, to determine the number of atoms of the element in the formula. So, for one atom, we will use mono. For 2, we will use di. For 3, we will use tri. For 4, we will use tetra. For 5, we will use penta. For 6, hexa. For 7, hepta. Then for 8, octa. For 9, nona. Then for 10, deca. There you go. Alright, so let's have some examples. So remember, these prefixes will indicate the number of atoms of the element in the compound. So let's have an example. So let's start with the most common compound. That is CO. Okay, so according to the rule, use prefixes for both elements present. So we will name the first element. That is carbon. And then add IDE to the root of the second element. So the second element, this is the root for that, and let's add IDE. Okay. However, I haven't used yet any prefixes, right? So how many carbon atoms do we have in the formula? We have 1. And for oxygen atom, we also have 1. So we cannot use mono at the beginning because that is according to the rule. Mono is usually omitted for the first element. Okay, so we will not use mono for the first element. But that is only for the first element. So we can use mono for the second. Sorry for that. We will use. Let me just adjust the frame. Okay, so we will use mono for the second element. Okay, something is happening. Let me just erase that. So we will use mono for the second element. So that will become a monoxide. Okay, so therefore the name for this compound is actually carbon monoxide, not monocarbon monoxide. Okay, mono should be omitted for the first element. So that is carbon monoxide. Mono here means that there is only one atom of oxygen. Alright? And let's have another example. Let's say we have N2O4. Okay, so let's name the first element, which is nitrogen. Then this time, since the first element is not one atom anymore, there are two atoms of nitrogen. So we can use di, or we will use di, the prefix di, for the first element. So dinitrogen, that means there are two atoms of nitrogen. Dinitrogen. There you go. And for the second element, so add IDE to the root term. The root term is this. Let's add IDE. That's oxide. Then let us add the prefix according to the number of atoms of oxygen. So since we have 4, we will use tetra. But instead of tetraoxide, we will assimilate it for easy reading, so it will become tetroxide. So the name for this compound is dinitrogen tetroxide. Alright? Let's have another example. Let's say PCl5. Okay, so let's name the first element, which is phosphorus. Since there's only one atom of phosphorus in the chemical formula, therefore no need to write mono. Okay, again, mono is omitted for the first element. Okay, then name the second element, add IDE to the root term of the second element. So this is the root term, and then add IDE. Alright, then we will add the prefix penta to indicate that there are 5 atoms of chlorine. So that is pentachloride. So the name for this compound PCl5 is phosphorus pentachloride. There you go. Okay, so I hope that that is already clear. And then let us go to these examples. For this list of compounds, usually we use these names for these compounds because it has been used even before or for a long time already. Instead of using the systematic way of naming, let's just use these names or their common names. So for B2H6 diborane, for CH4 methane, for SiH4 silane, NH3 ammonia, PH3 phosphine, H2O water, H2S hydrogen sulfide, which means that these names are more acceptable compared to the systematic name. For example, for H2O liquid. Alright, so if we're gonna use the systematic name, that would be, let's name the first element, which is hydrogen. Indicate the number of atoms of hydrogen using the Greek prefixes. So we have 2 here, so dihydrogen. Then add IDE to the root term. So this is the root term of the second element. Add IDE and indicate the number of atoms of the second element using the Greek prefixes as well. So we only have one. So the name for this using the systematic way of naming is dihydrogen monoxide. However, it is okay to use the term water because that is already acceptable universally or globally. So that's it. I hope you learned something new for today, or if not new, at least you learned more, or you mastered this topic through this video. So if this video has helped you, please hit like and subscribe. That's it. Bye bye. See you again.